Hi, we shall discuss now the lambda coefficient and the test associated with it. A brief introduction on what is lambda coefficient. Lambda coefficient, or better known as Goodman-Kruskal's lambda, is a measure of association for cross-tabulations between two nominal categorical variables. For two categorical variables A and B, lambda coefficient is used when we are interested in the error of predicting B and the error of predicting B given A. To be precise, the lambda coefficient tells us how much predictive error is reduced of one variable by knowing another. The lambda coefficient is given by the equation lambda sub b is equals to this equation right here, where P of E is the error in predicting B without the knowledge of A, and P of E given A is the error of predicting B with the knowledge of A. Kaya lambda of B ay dahil yung variable of interest na gusto natin i-predict ay yung variable B. And tinitignan natin kung may bababawas ba sa predictive error or yung probability na magkamali tayo sa paghula ng variable B given na may alam naman tayo mga bagay-bagay. And in this case, ito yon na P of E given A, or yung meron tayong idea kung ano yung mga values ni variable A. For the data, we now have this R by C contingency table, and we have this variable A, variable B, and these subcategories. We have the A's of I to be the ith category under variable A, I from 1 up to R, B's of Jth category under variable B, J from 1 up to C, and we have this observed frequency, N's of ij for ith row and jth column. Tapos meron rin tayong mga column totals dito na n i's of dot for the ith row total and n dot j for the jth column total. And we have big N denoted to be the total number of observations or total number frequency dito sa loob nito. For the assumptions, first, we only assume that we have two polytomies A and B. That is, we have two variables of interest A and B, A with R categories and B with C categories. 2. There is no natural ordering of interest. The data must be categorical in nature. Ang concern lang natin dito ay ang mga nominal variables. 3. Asymmetry holds true. The A classification precedes the B classification chronologically, causally, or otherwise. Kaya rin sinasabi na asymmetric ang lambda coefficient ay dahil yung test statistic na mapoproduce natin ay makikita natin na magkaiba. Hindi natin masasabi na lambda of A is equal sa lambda of B or otherwise. Dapat merong factor na nagkukos yung isa dun sa isa pang variable. For the hypothesis, let lambda of B be the measure of predictive error that is reduced of variable B, or rather reduced of predicting variable B given that we know A. We have the null hypothesis lambda of B is equals to some known value, lambda of B null, and the alternative hypothesis that meron tayong tatlo, greater than, less than, and not equal to. The measure ng predictive error that is reduced of predicting variable B given that we know A is not equal to, greater than to, or equal to some value lambdas of B null. For the decision rule, for the one-sided test, we have reject H null if Z is greater than Z of alpha for the greater than test, and we have reject H null if Z is less than or equal to Z of alpha if alpha of B is less than to alpha of B null. And for the two-sided test, we have the absolute value is greater than or equal to Z's alpha of 2, where Z's alpha is the upper alpha percentile of the standard normal distribution, N01. And we use table 8.1 kasi standard normal to. May kita natin mamaya kung bakit naging ganito yung decision rule natin ay dahil sa pag-formulate ng ng test statistic natin kung saan kinuha natin yung means and variance nung under H null, nung test statistic natin lambdas of B, tapos in-standardize natin. For the procedure, first, we sort the data into R by C contingency table, where R is the number of categories for variable A and C is the number of categories for variable B. Also, calculate the row and column marginal totals at the end of the table. 2. Find the highest frequency in each ith row, denoted by Rs of I, and get the summation of it. Then, proceed to get the highest column total, denoted by max n.c, and compute for Ls of B. Ito yung parang lambdas of B natin. Pero in this case, we denote this as Ls of B, which is equal to summation of Rs of I from 1 up to R minus max all over N of minus max ng maximum column total. Then, we now compute for the variance of Ls of B under H null, given by this formula right here. Same lang naman yung mga components except meron tayo nadagdag dito sa dulo, which itong part na to. At ito ay yung summation ng Rs of K for all K. Yun yung sum ng highest values in each row that is in the same column as the highest column total. Yun max and that's it. Then, we now compute for the test statistic Z given by Ls of B minus the lambdas of B null. Ito yung ina-assume natin na value dun sa problem. Makikita natin mami sa example. Over the variance, over the, not the standard deviation pala. For the remarks, first remark, Ls of B is indeterminate if and only if the population lies in one column. That is, lies in 1B categories. Kasi, ang magiging assumption natin dito ay yung N total. Kung isa lang naman yung column mo, edi yung N mo, equal na rin siya dun sa highest maximum column total. Edi magiging N minus some form na parang N lang din yung maximum column total. Kaya magzi-zero yung denominator mo. As well as kapag yung numerator naman, isa lang rin yung column mo. So, parang yung mga Rs of I mo ay same lang din. For the second remarks, the value of Ls of B lies in the interval 0 to 1, which is inclusive of 0 and 1. For the third remark, Ls of B is equal to 0 if and only if the knowledge of the variable A is of no help in predicting the variable classification, and therefore, knowing A contributes little to reducing the error prediction. This happens when the highest value in each row Rs of I is in the same column of the highest column total, max ng n sub dot c. For the fourth remarks, Ls of B is equals to 1 if and only if the knowledge of the variable A classification completely specifies the variable B. This happens when each row in the contingency table contains at most one non-zero frequency. For the fifth remark, when variable A and variable B are independent of each other, Ls of B is equals to 0. However, the converse is not necessarily true. We cannot say that the variables A and B are independent when Ls of B is equal to 0. For the sixth remark, Ls of B is unaffected by the permutation of rows or columns. This is due to the fact that the data that we have here is of nominal level, and it doesn't assume the ordering of the values in either of the variables A and B. Dito, ang pinapertain dito ay yung mga categories. Meron tayong R categories and C categories. So, for the last remark, Ls of B is not equal to Ls of A. That is, we can compute for Ls of A by using the highest row total naman dito. Maximum ng N R dot dapat to. Pero, and the summation of the highest frequency jth column, Cs of I naman. But it will not necessarily be equal to Ls of B. Thus, we can say that the lambda coefficient is asymmetric. At ito yung sinabi natin kanina dun sa assumptions natin, yung third assumption natin na some asymmetry holds between the two variables. We shall now discuss examples. Consider the artificial set of data below. Meron tayong variable A with 3 categories, ito yung R natin, and variable B with 4 categories, which is R columns. And we also compute for the marginal row total, ito, and marginal column total, which is here. And we have the big N to be equal to 50. We test at 5% levels of significance that lambdas of B is not equal to 1/3. Step 1. We shall state the null and alternative hypothesis. Let lambdas of B be the measure of predictive error that is reduced when predicting variable B given that we know A. That is, we have H null to be lambdas of B is equals to 1/3 versus the alternative that lambdas of B is not equal to 1/3. Then, for the step 2, we shall state the level of significance and decision rule. At 5% level of significance, we have alpha is equals to 0.05 and the decision rule to reject H null if the absolute values of Z is greater than or equal to Z of alpha over 2. Since we have a two-sided test. That is, reject H null if absolute value of Z is greater than or equal to Z of 0.05 over 2, which is equal to 1.96 from table. Then for this step 3, we shall now compute for the needed values and test statistic. Computing for L sub B, we have the values here. Ito yung mga maximum natin na values kada row. Step 3, we shall now compute for the needed values and test statistic. Computing for L sub B, we have this formula right here. Ito yung mga maximum value per row. So, sulit lang natin ulit kung ano yung mga values. Meron tayong 8, 5, 3, 3, 0, apologies. 8, 1, 0, 0, 4, 14, and 4. R's of I ay dinedenote kung ano yung mga maximum values per row. So, kung titignan natin dito sa first row, itong values na to, 8533, ang maximum value dito ay yung 8. So, ito yung first 8. Dito naman sa second row, meron tayong 0, 8, 1, 0, and 8 yung maximum values, kaya 8 rin to. And for the third row, we have 14 to be the maximum value, kaya 14. Kaya ito yung naging value ng summations ng R sub I natin. Then, computing for the L sub B, we have this formula right here, and substituting the values that we computed, we have 30 minus 18, kasi itong column na to, yung maximum column total natin, over 50 minus 18, and L sub B is equals to 0.375. Then, we shall now compute for the variance of L sub B under H null para makompute natin yung Z mamaya. And variance is given by this formula right here. Ito lang yung hindi natin alam, yung summations of R's of K for all K. So, sulat ulit natin yung values. Meron tayo 8, 5, 3, 3, Ang notation natin na ito, na summation ng R sub k for all k, ang nire-represent niya ay kung titingin ka dun sa highest column total, ito yon third column na to, isum down natin kung ilang values dito yung maximum siya sa row na yon. So, in this case, titingin tayo dito sa row na to, itong 3, 1, 14, then yung 3, kung maximum ba siya sa first row, hindi siya maximum. 1, maximum, ito ba ito pinakamalaki dito sa row 2? Hindi rin. 14, ito ba yung pinakamalaki dito sa third row? Oo. So, ang magiging values lang ng R sub k natin ay 14 lang, which is seen here. So, substitute natin yung mga values na na-compute. So, meron tayong variance to be equal to 400 all over 32,768. Then, computing for z, we have value of L of b, which is 0.3.75 minus the lambdas of b null, which is denoted to be 1/3 all over the square root of the variance. And we have z to be equal to 0.3771. And step 4, we shall now form a decision. Since z is equals to 0.3771, which is not greater than or equal to 1.96, we do not reject the h null. Then, for the conclusion, at alpha 0.05, we do not have sufficient evidence to say that the measure of predictive error that is reduced when predicting variable b, given that we know a, is any different than 1/3. Now, for the example 2, suppose we have a contingency table that has ties maximum yung highest column total. In this case, the highest column total is 16 pero dalawa sila, which is the second column and the third column. Then, we test at 5% levels of significance that lambdas of b is not equal to 0.3. Step 1. State the null and alternative hypothesis. Let lambdas of b be the measure of predictive error that is reduced when predicting variable b, given that we know a. So we have h null to be lambdas of b is equals to 0.3 versus the alternative that lambdas of b is not equal to 0.3. State the level of significance and decision rule. We have alpha to be 0.05. So our decision rule would be reject h null if the absolute value of z is greater than or equal to z of alpha over 2. That is, we have also the same same critical value as the previous example, 1.96. Then compute for the needed values and test statistics. Sulat ko lang ulit muna yung mga values. We have 9, so, looking at the first row, anong highest value dito? Itong 9. So, we have 9 here. And sa second row, ang highest value naman ay itong 10. Kaya, meron tayong 10 dito sa pangalawa. And for the third row, ang highest value dito ay 14. So, we have the summations of r sub I to be equal to 33. So, computing, we have 33 minus the highest column total. In this case, parehas lang naman sila ng value na 16. So, okay lang. 16 lang. And n to be 50. So, we have L sub b to be 0.5. Computing for the variance, we have two cases here. Meron. Kung i-consider natin na yung highest column total ay itong second column, meron tayong mga values sa column na 2, 10, and 4. Yung 2 ba ay highest sa first row? Hindi. Yung 10 ba ay highest sa second row? Yes. And yung 4 ba ay highest sa third row? Hindi. So, meron tayong summations of R's of k for all k na 10. And ito yung variance kapag kinonsider natin itong second column. Kapag third column naman yung i-consider natin as highest column total, ang R's of k na makakompute natin ay 14. Kasi 14 lang, itong value lang na 14 yung highest sa third row. So, ang makakompute natin na variance ay 29/2312 kapag i-consider natin itong second column, or 21/2312 kapag i-consider natin itong third column. Then, we now compute for z's, and we have z to be 1.7858. Ito yung kapag kinonsider natin yung second column versus yung isa naman na kapag kinonsider natin yung third column, ang lalabas ay 2.0985. To form a decision, since there is no current rule on what to do when there are ties in cases like this, it requires further investigation. We can see that the two test statistics computed yield different conclusions. One fails to reject the null hypothesis since mas mababa yun 1.78 sa 1.96, and the other rejects the null hypothesis. For now, we choose the column that will yield the smallest variance. Ang smallest variance ay yung 21/2312, yun yung third column. And we use the test statistic z to be 2.0985. Since z is equals to 2.0985 is greater than 1.96, we reject h null. And for conclusion, at alpha 0.05, we do not have sufficient evidence to say that the measure of predictive error that is reduced when predicting variable b, given that we know a, is different from 0.30. For the third example, the following table was used by Goodman and Kruskal as an example in the paper, and the data was originally given by Aman in their Anthropologie der Badener. Is there an association between eye color and hair color of the Badeners? Test the hypothesis that lambdas of b is greater than 0.20 at 5% level of significance. So, dito meron tayong 3 categories sa variable A. Variable A natin yung eye color. Meron tayong blue, gray, and green. And variable B yung hair color, which is fair, brown, black, and red. Stating the null and alternative hypothesis, let lambdas of B measure of predictive error that is reduced when predicting hair color, given that we know eye color. So we have the null hypothesis to be lambda of p is equals to 0.20, and versus the alternative that lambda of p is greater than 0.20. We state the level of significance and decision rule. At alpha 0.05, we reject h null if z is greater than or equal to z of alpha. That is, we reject h null if z is greater than or equal to 1.645. Computing for the needed values and test statistic, we have the maximum values per row to be 1768, 1387, and 438. So, yung summation nila ay 3593. So, meron tayong else of p to be this value 0.1924. Then, computing for the variance of variance of else of b under h null, yung R's of k naman natin doon ay ay mga values lang na papasok doon ay 1768 lang. Kaya mayroon tayong variance na ganito. So, computing for z, we have this form, and z is equal to be negative 0.6255. Forming a decision, since z is equal to negative 0.6255 is not greater than or equal to 1.645, we do not reject the null hypothesis. And we write a conclusion that at alpha 0.05, we do not have sufficient evidence to say that the measure of predictive error that is reduced when predicting hair color, given that we know eye color, is any different than 0.20. For the software applications, lambda coefficient can be solved in R by using the package desk tools. For this to work, this package must be first installed, and nakikita natin sa kanan kung ano yung syntax para i-install yung package na to. Meron tayo dito. And ito yung line na gagamitin natin para makompute yung lambdas of B. So, meron tayong function na lambda at yung mga arguments ay x, direction, and confidence level. X yung contingency table natin, kailangan i-store muna siya sa isang object. Tapos yung direction naman is set to symmetric by default. Pero since asymmetric ang lambda coefficient, i-define natin kung saan tayo titingin sa kanya, kung row or column. Then, confidence level naman yung sineset natin sa alpha. For the different examples, meron tayo dito. Ito yung contingency table natin. Tapos, since ang direction natin ay tinitignan natin yung B natin, which is nasa taas dito. So, direction natin is column. So, same lang na compute natin na else of B. Tapos, dito sa example 2, column pa rin yung direction natin. And, same pa rin yung lumabas na else of B. And, same with this example right here. Same yung na-compute na 0.1923949. So, that's it for lambda coefficient.
Before we proceed to the next topics, let us first discuss concordant and discordant pairs. Suppose we have observation x in the ith row index and jth column index. Also, we have another observation y in the kth row index and lth column index. A pair is said to be a concordant pair if the indices of y are both greater than x or both less than x. That is, I is less than k and j is less than l, or I is greater than k and j is less than l. So visually, ganito siya. These are the pairs that are in agreement with respect to the order of categories. Let us keep in mind that in the following topics, we deal with variables that are measured in the ordinal level. So, makikita natin na ang mga frequencies dito sa area na to, they belong to the categories that are lower than the category of x for both variables. So for example, this is small to large and this is low to high. Yung mga frequencies sa y are either smaller and lower than x or greater and higher than x. Kaya andyan siya. Yun yung meaning ng in agreement with respect to the order of categories. To compute for the number of pairs concordant with observation x, multiply the number of entries found in x with the sum of entries in the bottom right portion, those with indices that are greater than x. Note that the upper left portion is omitted in the computation to avoid double counting. So what we mean by this is, sa frequency na to, kung ano man yung frequency sa x, we multiply that by the sum of the frequencies here. And then we disregard this na. So ang gagawin lang natin, i-add natin yung mga frequencies that are below and to the right of it. And then we multiply that to the frequency found in x. Next naman, for discordant pairs. A pair is said to be a discordant pair if the indices of y are I less than k and j greater than l, or I greater than k and j less than l. So dito, kaya siya discordant kasi hindi na same yung direction ng inequalities. These are the pairs that are in disagreement with respect to the order of categories. What we mean by this is, kung titignan natin tong portion na to, the portion that is above and to the right of x, for one variable, the frequencies here belong to categories that are higher than the category of x. And for the other variable naman, lower siya than x, kaya siya in disagreement. And for the other portion naman, dito, for one variable, higher siya than x. For the other variable, yung categories na kinabibilangan niya ay lower than x. That's what we mean by disagreement with respect to the order of categories. So to compute for the number of pairs discordant with observation x, we multiply the number of entries found in x with the sum of entries in the bottom left portion. Note that the upper right portion is omitted in the computation to avoid double counting. So ganun din, ang gagawin lang natin, we multiply the frequency here, which is x, the frequency here, with the summation ng frequencies that are below and to the left of it. Ayun. To compute for the total number of concordant pairs, which is denoted by n sub c, the formula is given by n sub c equals the double summation of n sub ij and x sub ij, I from 1 to r and j from 1 to c, where we further define x sub ij as the double summation of n sub kl, where k is greater than I and l is greater than j. So when you further analyze this formula or formulas, malalaman nyo na, makikita nyo na x sub ij is simply the summation of the scores that are below and to the right of x sub ij. And to compute naman for the total number of discordant pairs, which is we denote as n sub d, the formula is given by n sub d equals the double summation of n sub ij, big Y sub ij, I from 1 to r and j from 1 to c, where we define y sub ij as the double summation of n sub kl, where k is greater than I and l less than j. So again, kapag in-evaluate natin itong formula na to, we just see na y sub ij is simply the summation of the scores that are below and to the left of n sub ij. So basically, ito lang yung computational formula for concordant and discordant pairs, pero diniscuss na natin to kanina. So for example, we're gonna get the total number of concordant pairs. Yung summation, there are gonna be the same number of terms as the number of frequencies here. So for the first term sa summation and computing for concordant pairs, the total number of concordant pairs, we get the frequency here n sub 1, 1, and we multiply it by the summation of these frequencies. So i-add natin lahat yan, and then i-multiply natin siya sa frequency na to. And then for the next term in the summation, gagawin natin siya sa n sub 1, 2, tapos itong mga frequencies naman. And then we move on hanggang makarating tayo sa n sub rc. And for discordant pairs naman, we just do that, pero yung i-multiply natin by the cell are the frequencies that are below and to the left of it. So for the first term naman in that summation for discordant pairs, you can see na wala namang frequency that is below and to the left of n sub 1, 1. So we multiply it by 0. So that term will be equal to 0, and we move on to the second term. And sub 1, 2, we multiply that by the frequencies that are below and to the left of it. Kaya i-add natin yan, itong mga frequencies na to. And then we multiply that by this frequency and sub 1, 2. And we move on hanggang makarating tayo sa last frequency in the table. And take note na baka malito lang tayo na baka masama natin yung mga marginal totals, yung row and column totals. So, wag natin isasama yun. So, ayan. We're all set. Alam na natin yung concordant and discordant pairs. We're ready to learn the next topics.
We will now talk about the Goodman and Kruskal-Gamma statistic G. For the introduction, the Goodman and Kruskal-Gamma measures the strength and direction of association between ordinal level variables. The gamma statistic is proposed in paper by Leo Goodman and William Kruskal. The lowercase Greek letter gamma will represent the population parameter estimated by the correlation coefficient. G will represent the sample statistic used to estimate the value of gamma. The previous reporters have already discussed the other measures of rank correlation, and these are Kendall's and Spearman rank order correlation coefficients. They are used to analyze the relationship between two variables A and B. However, when the data has numerous tied ranks, the Goodman and Kruskal-Gamma statistic G is preferable since it is more efficient for data with dimensions of R by C. For example, you could use the Goodman and Kruskal-Gamma to see if there is an association between employees' job satisfaction and their level of performance. For the data, since gamma is a bivariate measure of correlation or association that is employed with rank order data, the data is summarized in an ordered R by C contingency table with R rows and C columns. Each of the rows in the contingency table represents one of the R levels of the A variable, while each of the columns in the contingency table represents one of the C levels of the B variable, or vice versa. The two variables A and B may consist of any number of categories, where A sub I is the ith category under the variable A, I is from 1 up to R, P sub j is the jth category under variable B, j is from 1 up to C, and sub ij is the observed frequency for the ith row and jth column category, n sub dot j is the jth column total, n sub I dot is the ith row total, big N is the total number of observations. The first row in the table represents the category that is lowest in magnitude on the A variable. The ith row represents the category that is highest in magnitude on the A variable. The first column represents the category that is lowest in magnitude on the V variable, while the cth column represents the category that is highest in magnitude on the B variable. Note that the gamma statistic is symmetric, meaning you don't need to define which are the dependent and independent variables. For the assumptions, we have two. First, the two variables should be measured at the ordinal level. For example, the order of the size is small, medium, and large. Ordinal variables also include Likert scales. There is no natural ordering of interest. The data must be categorical in nature. Second, since the contingency table is ordered, the categories for the row and column variables are arranged in sequence with regard to their magnitude. There should be a monotonic relationship between the two variables. There is a monotonic relationship if both variables increase at the same time or when one variable increases while the other variable decreases. As for the hypothesis, let gamma be the association of scores or the categorization of subjects on variables A and B. For our null hypothesis, gamma is equal to 0, meaning there is no significant association between variables A and B. For our alternative hypothesis, gamma is greater than 0, gamma is less than 0, gamma is not equal to 0, meaning there is a positive or negative significant association between variables A and B. Note that if the alternative hypothesis is supported, then the null hypothesis is rejected. For our decision rule, for the right-tailed one-sided test, if gamma is greater than 0, reject the null hypothesis if C is greater than or equal to the tabled critical one-tailed value at the prescribed level of significance and if C is positive. For the left-tailed one-sided test, if gamma is less than 0, reject the null hypothesis if C is less than or equal to the tabled critical one-tailed value at the prescribed level of significance and if C is negative. For the two-sided test, gamma is not equal to 0. We check the null hypothesis if the absolute value of C is greater than or equal to the table's critical two-tailed value at the prescribed level of significance, where C sub alpha is the upper alpha percentile of the standard normal distribution. Use table 8.1. For our procedure, first, sort the data into R by C contingency table, where R is the number of categories for variable A and C is the number of categories for variable B. Also, calculate the row and column marginal totals at the end of the table. Second, compute for the number of concordant pairs n sub C and discordant pairs n sub D, where n sub C is equal to the double summation of small n sub ij times big X of ij, where big X of ij is the summation of the scores that are below and to the right of n sub ij, while n sub D is equal to the double summation of small n sub ij times big Y sub ij, where big Y sub ij is the summation of the scores that are below and to the left of n sub ij. Next, compute the Goodman and Kruskal-Gamma given by n sub C minus n sub D all over n sub C plus n sub D. The estimator gamma only uses the number of concordant and discordant pairs of observations. Last, compute for the test statistic given by G times the square root of n sub C plus n sub D all over big N times the quantity 1 minus G squared. Remarks: the gamma statistic G ranges between -1 to 1, so it's just like the Spearman-Franks correlation coefficient. If G is equal to 1, it implies a perfect positive correlation, meaning as variable A increases, variable B also increases. If G is equal to -1, it implies a perfect negative correlation, meaning as variable A increases, variable B decreases. If G is equal to 0, it implies no correlation between the two variables. Second, there are no correction needed for ties. Third, the gamma statistic G can be interpreted as the proportion of rank pairs in agreement. Fourth, for 2 by 2 tables, the gamma is equivalent to U less Q, where Q is equal to A times T minus B times C all over A times T plus B times C. It is used to analyze the strength and direction of association between two dichotomous variables. An example of a dichotomous variable would be gender. It has two categories, males and females. Another example would be coin flip. It has two categories, heads and tails. And the values for the U less Q also ranges from -1 to 1. Last, gamma statistic G can fit tables of any size, meaning the data can have any number of categories. Examples: suppose a researcher wants to find out if there is an association between a person's weight, which will be our variable A, and birth order, which will be our variable B. 300 subjects were assigned to one of the three categories of weight, which are underweight, normal, and overweight. The subjects were also categorized by their birth order. Test at 5% level of significance whether there is significance association between a person's weight and birth order. So we have a 3 by 4 contingency table with 3 rows and 4 columns. Step 1, state the null and alternative hypothesis. Let gamma be the measure of association between the weight and birth order of a person. We let our null hypothesis be gamma equal to 0 against the alternative gamma is not equal to 0. Step 2, state the level of significance and decision rule. Alpha is equal to 0.05. For our decision rule, since this is a two-sided test, we will check the null hypothesis if the absolute value of C is greater than or equal to C sub 0.025, that is also equal to 1.96. Step 3, compute for the needed values and test statistic. So we compute for the concordant and discordant pairs first, n sub c and n sub d. So here's the step-by-step solution for computing for n sub c and n sub d. We first compute for n sub c. N sub c is equal to the double summation of small n's of ij times big X of ij, where big X of ij is the summation of the scores that are below and to the right of n's of ij. So first we begin with a cell in the upper left hand corner of the table, which is cell sub 1, 1. Any subject who falls within a cell that is both below and to the right of the cell sub 1, 1 will form a concordant pair with any subject in cell sub 1, 1. We then determine the frequency of the cell and multiply the frequency by the frequency of the sum of all the other cells in the table that are below it and to the right of it. So we have 65 times the quantity 50 plus 15 plus 20 plus 10 plus 30 plus 20 is equal to 9,425. Next, we do the same procedure employed in cells of 1, 1. So we are now on cells of 1, 2 for underweight and second-born. We look at the rows below the underweight and to the right of the second-born, which leaves us with these frequencies. So the next term is 30 times the quantity 15 plus 20 plus 30 plus 20 is equal to 2,550. For cells of 1, 3, which is underweight and third-born, the sum of the frequencies of all the cells that fall below the underweight row and to the right of the third-born column is 25 times the quantity 20 plus 20 is equal to 1,000. For cells of 1, 4, there is no column to the right of the fourth-born column, thus the frequency of this cell will be multiplied by 0. Then we do the same for all of the other cells. Next, we compute for n sub d. We begin the cell in the upper right corner of the table, cell sub 1, 4. Then we look at the frequencies below this row and to the left of this column. So we have 5 times the quantity 15 plus 50 plus 15 plus 15 plus 10 plus 30, which is equal to 675. Next, for cells sub 1, 3, we look at the frequencies below the row and to the left of this column. So we have 25 times the quantity 15 plus 50 plus 15 and plus 10, which is equal to 2,250. For cells of 1, 2, we look at the frequencies below the underweight row and to the left of the second-born column. So we have 30 times the quantity 15 plus 15 is equal to 900. For cells of 1, 1, there is no column to the left of the first-born column. Thus, the product will be 0. Then, do the same for all of the other cells. This is the summary of computation for n sub c and n sub d. Step 3, substitute the values computed. So we got 16,675 for the concordant pairs and 6,050 for the discordant pairs. Next, compute for the Goodman and Kruskal-Gamma. We just have to plug in the values that we got from the concordant and discordant fields to the equation of the Goodman and Kruskal-Gamma. So we get 0.4675. Note that the value of G is positive since the number of concordant pairs is greater than the number of discordant pairs. And since G is positive, it suggests that the higher the rank of a person's weight category, also the higher the rank of the person's birth order category. Next, compute for the test statistic. We just plug in the values on the formula for the test statistic. We get 4.6028. Step 4, form a decision. Since C is equal to 4.6028 and it is greater than 1.96, reject the null hypothesis. Step 5, write the conclusion. At alpha 0.05, there is sufficient evidence to conclude that there is a significant association between a person's weight and birth order.
Example 2. Suppose a researcher had the scores of respondents in respect of two variables, social status and their desire for significant accomplishments, also known as their achievement rate, for 50 sample students as shown below. Determine whether any significant association exists between the social status and the achievement age of their children at school at 5% level of significance. Let's proceed to the solution. For the first step, let us state the null and alternative hypothesis. But first, let's define the parameter. Let gamma be the measure of association between the social status and achievement age of a student. Our null hypothesis would be gamma equals 0 versus our alternative hypothesis. Gamma is not equal to 0, or there is a significant association between the social status and achievement age of a student. For step 2, let's state the level of significance and decision rule. As stated earlier, alpha equals 0.05, and the decision rule would be to reject H null if the absolute value of the test statistic z is greater than or equal to z sub alpha over 2, or z sub 0.05 over 2, which is equal to 1.960. So now we have to compute for the needed values for the test statistic. And first we compute for the concordant pairs. For the total number of concordant pairs, here's the solution. We could confirm that for each term, the digit outside the parenthesis corresponds to the individual frequencies in the table, and then inside the parenthesis naman are the frequencies that are below and to the right of this frequency. So ganun din for the rest, and mapapansin natin na for the concordant pairs, we disregarded the last column and the last row since for these frequencies, wala namang makikita na below and to the right sa kanila na frequencies. And then for the discordant pairs naman, ganun din yung digit sa labas ng parenthesis ay yung individual frequencies na makikita sa table. And then yung nasa loob ay yung frequencies that are below and to the left of that frequency. So, inisa-isa din natin yung mga frequencies doon, and we disregarded the first column and last row since for these frequencies, walang matatagpo ang frequency below and to the left of them. So, nakuha natin ay n sub c equals 325 and n sub d equals 269. These values will be needed in computing for the test statistic. And now we compute for the Goodman and Kruskal gamma. G equals, ayan, i-plug lang natin yung total number of concordant and discordant pairs sa formula. And makakuha tayo ng value na 0.0943. So, ngayong alam na natin itong G, pwede na natin makompute ang test statistic. Z equals, we plug in G and also n equals 50 since our sample is 50. And then plug in din natin yung concordant and discordant pairs. At makakuha natin ay 0.3264. So we form a decision since Z equals 0.3264 is not greater than or equal to 1.960, we do not reject the null hypothesis. And our conclusion for this would be, at alpha equals 0.05, there is no sufficient evidence to conclude that there is a significant association between a student's social status and his desire for significant accomplishments. And now for the software applications. Goodman and Kruskal's gamma can be solved in R by using the package DeskTools. For this to work, this package must be first installed, kaya ang una sa syntax ay library desk tools. Ayan. And then next, Goodman Kruskal-Gamma, and inside the parenthesis would be first the contingency table, which we now call X muna, and then confidence level, which is just the confidence level, 1 minus alpha. So, balikan natin yung previous examples. Siyempre, mauuna yung library parenthesis desk tools. And then, we input the matrix, which we learned in previous stat courses. So, ito yung contingency table kanina. Nilagay lang natin. Ito yung mga frequencies. And we named the matrix contingency. Kaya sa next naman na command, Goodman Kruskal-Gamma, ang first argument ay contingency since it's the name of the matrix, and then confidence level of 0.95 since our alpha is 0.05. And binigyan tayo ni R ng Goodman and Kruskal-Gamma value. Ayan. And ganun din makikita sa example 2, ito yung contingency table and ito yung Goodman and Kruskal-Gamma. And mapapansin natin na hindi pa tayo bibigyan ng decision ni R. We're still left to compute it for ourselves. So parang ginawa lang niya yung part of the solution pero kailangan pa rin natin mag-manually compute on our own. Ang ilalabas lang niya ay yung value ng Goodman and Kruskal-Gamma. So ayun, that's it for your software applications. If you wanna practice pa, here's an exercise that you can work on.
Hello, and welcome to the third part of the discussion. Now let us talk about Sommer's delta. So what is Sommer's delta? Sommer's D or Sommer's delta is a measure of strength and direction of association between two ordinal variables, one of which is a dependent variable and the other being an independent variable. So medyo similar siya sa Goodman and Kruskal-Gamma. Kaso nga lang sa Sommer's delta, meron na tayong ditong dependent at saka independent variable. And dito sinasabi natin na yung independent variable natin is may effect sa dependent variable. A simple illustration to demonstrate this is determining association between the quality of service provided by a company and customer satisfaction rating. Here, the independent variable is a service quality, while the dependent variable is a customer satisfaction rating. Sommer's D measures how service quality affects customer satisfaction. So for the data, similar sa mga napag-usapan din nating mga topics, yung Sommer's D also uses an R by C contingency table. Pero, make sure natin dito na iset natin yung variable B at variable A. Dito, yung variable B natin is your dependent variable, while your variable A is independent variable. Important to kasi yung mga formulas na ginagamit natin dito, as well as yung interpretations, is naka-anchor sa form na kung saan variable B is dependent and variable A is independent. So para hindi na tayo mahirapan, make sure na lang na follow natin yung form na ganito na kung saan variable B is dependent again and variable A is independent. And ito yung form ng ating table. So for the assumptions, meron tayong dalawang assumptions dito. First, the two variables must be recorded in ordinal scale. So ito nga yung sinabi kanina na dapat ordinal siya. And second, and additionally, the researcher must predetermine which between the two must be the dependent and independent variable. Important to kasi sa may Sommer's D ay yung ating interpretations as well as yung calculations is nakadependent kung sino yung dependent at sino yung independent variable natin. So make sure na ma-set natin yun kung sino talaga yung dependent at saka independent variable when we are in Sommer's D. And second, there is a monotonic relationship between the dependent variable and independent variable. That is, there needs to be an increasing or decreasing relationship. So for the hypothesis, let DBA be the measure of association of independent variable A in relation to dependent variable B. So for this one, medyo important yung ordering dito ng subscripts. Medyo important yung ordering ng subscripts dito. That is, DAB is different from DBA na pinag-uusapan natin dito. So, kapag DAB yun, yung independent variable mo na doon is variable B, and yung dependent variable mo doon is A. And hindi yun the same sa DBA. Pero for this one, for this discussion, let us focus sa DBA. For the null hypothesis, dBA is equal to 0. That is, there is no significant association from variable A in relation to variable B. So dito, makikita natin na important yung order. That is, from A to B. Kasi, kapag pinaliktad mo yun, magiging DAB na yon. That is, as previously mentioned. And again, focus natin dito is DBA. Kaya, from A to B. And for the alternative hypothesis, there's a significant positive kapag DBA natin is greater than 0, significant negative if DBA natin is less than 0, and significant association lang if not equal to from variable A in relation to variable B. So, for the decision rule, yung test statistic ng DBA is in the form of Z. So, kapag yung alternative natin is in the form of DBA greater than 0, reject null if Z is greater than or equal to Z sub alpha. For kapag DBA is less than 0 naman, reject null if Z is less than or equal to negative Z sub alpha. And for the two-sided test naman, if yung alternative natin is in the form of DBA not equal to 0, reject null if absolute value of Z is greater than or equal to Z sub alpha over 2. So for this one, we will use table 8.1. So for the procedure, first, determine the dependent and independent variable between the two ordinal variables. So this is an important step as previously highlighted. Second is sort the data into R by C contingency table, where R is the number of categories for variable B and C is the number of categories for variable A. Third is compute for the number of concordant pairs NC and discordant pairs ND and tied pairs NT. So dito, bumabalik na naman yung concept ng discordant pairs at concordant pairs. Pero may bago tayo dito, yung tied pairs. Yung tied pairs is siya yung total number of pairs minus the sum of concordant and discordant. So, more on that later, pero mas easier to visualize yun kapag may example na tayo. And for the fourth one, compute for the value of DBA given by ito. So, yung form na ito is just NC minus ND minus yung denominator na ito is a total number of pairs. That is NC, number of concordant pairs, number of discordant pairs, and the number of tied pairs. Kapag pinagsama mo yan yung total number of pairs. So, for the fifth one, yung procedure na ito, compute for the variance of DBA under HO given by ito. So, medyo intimidating nga yung form na ito, pero ito yung variance niya. And moreover, medyo i-expand pa to yung AIJ at DIJ. And for the sixth part ng procedure, compute for the test statistic given by Z is equal to DBA over square root ng variance of DBA under H null. So ito, yung form na ito is in the form of X minus EX all over variance of X. Pero yung expected value of X natin dito, na expected value of DBA under H null, is naset natin to be 0. Kaya, wala siya sa form natin na ito. And that means na nagsisimplify siya sa form na ito, which is just your standardization. Kaya Z siya. So now, for the AIJ and DIJ, ito yung parang technical notation niya. Medyo magulo nga lang siya in terms of medyo magulo siya kapag intindihin ng ganitong form, pero kapag i-visualize mo siya, medyo mas madali siyang makita. So, in other words, AIJ is the sum of entries whose row and column indices are A, both less than I, and J. Ito yon, less than I, and less than J. Ito yun. And second, both greater than I and J. Ito yun. Ito yung part na yun. So, para makuha natin yung AIJ, isum natin yung part na ito at part na ito. And for the DIJ naman, ito yung parang opposite niya. Like, in other words, it is the sum of entries whose row and column indices are greater than I but less than J. Greater than I Saglit lang. Greater than rho, greater than I, but less than j. Ito yun. And less than I, greater than j. Ito yun. So, para ma-compute natin yung Dij, sum natin, similar sa Aij, sum natin yung mga number of entries sa parts na ito. So, more on this later on sa examples. So, for the remarks, first, the possible values of Sommer's D is in the interval -1 to 1, since it is the measure of strength and direction. Remark number 2, similar to correlation, its absolute value denotes the strength. So, meaning, value is closer to 1 in terms of absolute value to mean a stronger asymmetric correlation, while value is closer to 0 denotes weaker correlation. When the value is 0, it means no correlation. So dito, additionally din dito, meron din tayong positive at negative. Kapag negative siya, meaning negative asymmetric correlation. Ibig sabihin nun ay kapag nag-i-increase yung independent natin, ay nagdi-decrease yung dependent natin. Kapag positive naman, ibig sabihin nun, as we increase naman sa independent, nag-i-increase din yung dependent natin. So, for Sommer's D is similar to Goodman and Kruskal-Gamma, but differentiates which is the dependent variable and independent variable. So, yun na yung highlight natin kanina. And Sommer's D is more appropriate to employ when differentiating this. So, tama nga. Ito, the subscript used in Sommer's D is order specific. That is, DBA is different from DAB, as previously mentioned kanina. The first entry in the subscript denotes the dependent variable, and for instance, yung DBA natin, kapag ito yung pinag-uusapan natin, B is your dependent variable and B is your dependent and A is your independent. Pero, for generality na lang, yung default natin is DBA, which is yun yung commonly used naman. So, stick na lang muna tayo sa DBA. So, note that from the data section, variable B is the row variable and dependent variable. So, variable B, ito yon. Variable B is your row variable. Row variable meaning ito. Ito yung dinadenote niya. And is the dependent variable, as previously mentioned. Likewise, yung variable A natin is your column variable and your independent variable. Ito yun. And under the test for significance, remark number 6 na to, under the test for significance, it is important to note that it only implies association of independent variable A into dependent variable B. It is invalid to conclude the other way around since Sommer's D is order specific as previously mentioned. So kanina, sinasabi nga natin na i-bias si DBA sa DAB. Kaya, make sure natin na kapag nagsusommer's D tayo, particular tayo sa ordering. Kasi, yung interpretations natin is mag-iiba depende sa order niya. More on this later, makikita natin ito sa next example. So, ito na yung examples. So, for example, suppose a researcher is interested if time taken to finish a task is associated with stress levels. To conduct the test, the researcher has tested this to 60 randomly selected participants. The contingency table is shown below. Here, the independent variable is time taken to finish a task. The dependent variable is stress levels. Compute for Sommer's D. So, medyo simple na muna tayo. Mag-start muna tayo sa simple. So, for this one, as previously mentioned, important na identify natin yung variable A at variable B. So, for this one, sinasabi natin na yung independent natin ay time taken to finish a task. And your dependent is stress levels. So, meaning, yung independent variable natin, this one is A, at ito, si B. So, ito yung form na dapat follow natin dito. And iba ito sa dito kasi mag-iiba na yung meaning nito kapag ito yung ginawa natin. Like, kapag ito na yung kapag dito tayo, sinasabi natin na yung stress levels ay nag-a-affect sa time taken to finish a task. Pero for this one kasi, yung interest natin is the otherwise, yung time taken to finish a task affects stress levels. Kaya ito yung gamitin natin, yung A to B. And this one follows the form of DA. Kasi B is your dependent and A is your independent. B is your dependent and A is your independent. Kaya ito tayo. From independent variable to dependent variable. Gets? Okay. Ito yun. So, for the Sommer's delta, ito, medyo mechanical yung computation natin dito. So, again, concordant pairs, discordant pairs, and tied pairs. So, for the concordant pairs, ito yung computation. So, gagawin natin to for each entry. So, 8. And ano yung pairs na concordant dito? So, ito yung mga entries na concordant dito sa 8. So, 8 times the sum of this part. Similarly, gawin na natin to for 6. So, yung concordant dito is yung entries na ito. Ito. So, meaning, multiply natin yung 6 sa sum ng entries na ito. Ito. And for 4, wala tayong concordant dito, kaya 0 siya. Next is 5. And yung concordant natin dito is ito. Kaya sum din natin to. And for this one, ito, then ito. Multiply. So, following that, ito yung computation sa atin. Ito yung breakdown ng ating computations. As you can see, yung sum natin, at sum natin yung total entries na yon, sum natin yung total na yon, and that gives us 639. And for the ND naman, yan yung parang opposite na naman. 4, at ito yung discordant sa kanya. 6, and ito yung discordant sa kanya. 8, wala tayong discordant pairs yan, so move tayo. 6, then ito yung discordant. And 9, ito yung discordant. And as you can see, ito yung computations. So for the tied pairs na naman, yung ginagawa lang dito is actually, you get the column sums at multiply mo siya sa possible combinations. For example, 14 times ito and 14 times ito. As seen here. Ito yun. And for the other part, this times this. So parang nagko-combination ka lang na combination na ito at ito, combination na ito at ito, and combination na ito at ito. So sum that up, what you get is the total number of pairs. Ito yung total number of pairs. Pero kapag tied pairs ang pinag-uusapan, dapat isubtract din natin yung total number of concordant pairs at discordant pairs, which is given by which is from this. Ito at ito. So yun, makikita natin na subtract natin yun concordant at discordant pairs. So yung number of tied pairs natin, total niyan is 352. So plugging in, ito yung formula ng DBA for Sommer's T. Kasi nga, di ba, DBA yung pinag-uusapan natin. So for that, ang yung value ng DBA natin is 0.3908. So yun. So ito naman, example 2. This one, mag-hypothesis test tayo. So suppose a high school teacher is investigating if there is an association between time taken to finish the exam and quality of test scores. To conduct this, the teacher randomly gathered data from 40 randomly selected students. The teacher noted the time taken for every student and categorized the student's test score quality based on the exam results. And ito yung contingency table niya. And at alpha is equal to 0.05, can we conclude that time taken is associated to test scores quality? So ito yung setup niya. ito yung table niya na binigay. So, for this one, step 1, state the null and alternative hypothesis. So, define natin kung ano yung DBA. So, let DBA be the association from time taken to test course quality. Again, important na to. From time taken to test course quality. Important yan sa Sommer's delta. So, for the null hypothesis, set natin na yung DBA is equal to 0 and yung alternative natin is not equal to. Second is step 2, state the level of significance and decision rule. So, alpha natin is 0.05 and decision rule is kasi dito not equal to, so meaning yung decision rule natin is reject null if yung absolute value ng z natin is greater than or equal to z sub alpha over 2. At kasi dahil si alpha natin ay 0.05, meaning yung z sub alpha over 2 natin ay 1.960. Step 3, compute for the needed values and test statistic. So, again, concordant pairs and discordant pairs. So, ito na yung breakdown ng concordant at discordant pairs. At calculate nyo na lang at double check nyo kung same din yung answers na nakuha nyo. So, plugging in the values, ito yung makukuha nating Sommer's delta. And again, at proceeding naman sa variance. So, ito na yung medyo madugong part kasi yung gagawin natin dito, for every entries, if maalala nyo kanina, yung Aij at Dij. So, for example, galing tayo dito. Yung Aij natin dito is wala tayo sa itaas dito. Wala tayong to this part. So, meaning, ito, pero meron tayong dito. Ito. So, meaning, Aij natin is sum of these entries. Pero, wala tayong Dij. So, meaning 0 yun. For this one, Aij natin is ito. And Dij natin is ito. So, subtract mo yung sum ng entries nila and multiply mo. Subtract mo yung sum ng entries ng Aij at Dij, square mo, then i-multiply mo sa 4. And ito, Aij natin, wala tayong Aij dito, pero Dij natin ito. Ito yung Dij natin. For this one, ito yung Aij natin, pero wala tayong Dij. Tama. Meron pala. Ito. Aij natin ito. Again, Aij and Dij. For this one, Aij is this. And Dij natin is this one. And so on and so forth. So, kapag ginawa mo yun, for all entries, yung makukuha mong sum doon, yung makukuha mong summation doon is 570. And plugging in yung mga values na nakuha natin previously, ay yung makukuha nating variance ay 0.0253. Ito yun. And plugging in yung mga values na nakuha natin previously from DBA, ito yun. At yung variance, plugging in sa test statistic, yung makukuha nating values ay 1.102. So, form a decision, step 4. Since z is equal to 1.102, which is clearly not greater than or equal to 1.960, we fail to reject the null hypothesis. So, conclusion natin dito, at alpha is equal to 0.05, we have insufficient evidence to conclude the time taken to finish the exam has an association to quality of test scores. So, for the software application naman, ito yung paano mag-code ng Sommer's D into R. So, yung syntax nito is ito. Ito lang naman yun. Pero, for this one to work, kailangan nating i-install yung package na DeskTools. So, kapag viewing on the syntax na binigay dito, yung library DeskTools, yan yung nag-load ng package na DeskTools. And yung Sommer's Delta na code na mismo is given by this one. Ito. So, for the arguments nito, X is your contingency table. Direction is equal to, pwede siyang maging row or column. By default, row yung nakaset, and that is your DBA. And for the confidence level, yan yung confidence level natin na sineset natin. So, balikan natin yung mga previous examples. So, kanina, sa example 1, yung na-calculate natin doon ay same din dito. 0.39 din. At for example 2, same din. And check natin na sa ating syntax na nilagay natin ay direction is equal to row kasi DBA yung kinakalculate natin at confidence level at 0.05. Ito yun. And ito yun. For example 2. So that ends the presentation, and here are our references for the presentation. So thank you for listening and have a good day.